Hello everyone. Welcome to the video lecture series of the subject Electrical and Electronics Engineering. And we are studying the chapter Analog and Digital Circuit. Here we will see the analog and digital converters. That means analog to digital and digital to analog. So how this presentation will flow? So we will see the introduction of analog to digital converter and digital to analog converter. We will see the types of analog to digital and digital to analog converter and the application of analog to digital and digital to analog. So let's see first the introduction of ADC to the DAC. So you can see this diagram. In this diagram, this is the physical variable. So any physical variable like pressure measurement, weight measurement, any type of the physical quantity can be converted to the electrical signal by using the transducer. So this transducer will convert this physical signal to the electrical signal, and that electrical signal will be analog in the nature. So you need to give it to the analog to digital converter. This will convert the signal in the digital. So now the digital signal is converted. This digital system will do some mathematical or logical operation on that signal to increase the magnitude of that signal, or to add with some signal, to multiply with some signal. So this digital system will do so many functions. And after doing that function by this digital path, we are again giving it to the digital to analog converter. So this digital to analog converter again convert this to the analog. So here the again output is the analog. This analog is output. It is given to the accurator. Accurator will accurate any errors occurred in this conversion process, and finally it is given to control the physical variables. So in this way, this is the application why we are using the analog to digital and digital to analog converter. Now let's see what is ADC, that is analog to digital converter. So analog to digital converter is an electronic device that converts the continuous analog input signal to the discrete digital numbers, that is in the binary form. So it will convert the analog to the binary digital. That means analog signal is continuous type of signal and digital signal is discrete type of signal. The real world signals the constant and noise continuous in time. This is analog signal. Digital signals are discrete in time and value, and binary digits that contains the values 0 and 1. So this is analog type of system, this is digital type of system. This give you the constant output and this give you only output 0 and 1. So this was ADC. You can see this is the analog signal. This is continuous in nature. So at any moment, at any time, you can find the value of your signal. Let's say that this is some voltage. And if we talk about the digital signal, then digital signal is having two types of value. Either 0 value or the 1 value. So here you can see that the signal is having 1 value. It falls down 0, 0, 1, 1, 0. So this type of signal is known as the digital signal, and this type of signal is known as the analog signal. Now let's discuss some importance of this analog to digital signal. Or microcontroller, all type of the microcontroller stores the information using the digital logic. Compress the information to the digital form for this efficient storage. Medium for storing the digital data is more robust. So digital data transfer is more efficient. And by all this means, ADC is important. And digital data is easily reproducible. As I said that you can multiply, divide, add, subtract. You can do so many things on the digital signal. So that's why we need to convert the analog signal into the digital signal. And also it provides a link between real world signals and the data storage. So any real world signals can be converted into the digital form, and that digital data can be stored. So any real link, or you can say any real world data, can be converted into the digital and it can be stored. Let's see this type of signal, that is ADC working of the ADC. So as I said that one example application of the ADC and DAC both. One person is speaking to the So it should be given to the ADC, that is analog to digital converter. Then it is given to, once this is converted into the digital, it is given to the digital system. This digital system will do the increment or amplification process. So the signal will be amplified. And this is DAC. So again, the digital signal is converted into the analog signal. And this digital to analog signal now given to the output device, that is speaker. And so that if this person speaks at very low volume, even if he speaks at the very low volume, we get the output at very high volume. So in this way, this ADC and DAC works. You can see analog signal was given, it was converted into the digital signal, and output is again obtained as the analog signal. So in this way, this analog and digital system works. You can see another diagram also. Analog input should be given to the ADC, that is analog to digital converter. So this will convert the analog to digital, and output of the digital will be like this: D0, D1, D2. This is 1:3 ADC. There are so many type of ADC in which you can change the number of output pins. So this is the binary output taken out from the ADC. Now let's see the analog to digital converters block diagram. So first of all, analog signal is given to some sample circuit. So this sample circuit will sample out the data. Sample out the data means it will find the data at various values. So it will give the continuous in time and continuous in amplitude. So here the signal was given was continuous in time and continuous in magnitude. But at the output of this sample circuit, this will give you the signal as discrete in time. Means it is not now obtained at all the values of the time, but it will be giving you the signal at different time interval. So this will be discrete in time and continuous in amplitude. So amplitude will be continuous, but the signal is taken at different time, not between two times. Here the signal was at all the time, means you can find the value of the signal at any time, but here you cannot find the signal at any time, but you can find the signal's magnitude at specified time only. After that sample circuit, holding circuit is there. So what this holding circuit will do? This will do the discrete in time and continuous in amplitude, but it holds the data for some amount of time. So what is the use of this holding circuit? Because this analog to digital converter is continuously converting the data. So once this data is not passed through, he should hold the data. And then once the signal is applied to this hold circuit, now it should be given to the next part, so that the two data should not be mixed. So after this holding circuit, quantize is given. So this quantize will convert the signal at discrete in time and discrete in amplitude. So signal's amplitude will be now discrete. Finally, it is given to the encoder, which will encode the digital signal, and this digital signal is discrete in time and amplitude is in binary form because we have quantized that signal. So now the signal is in the binary form. So that means now we obtain the answer in digital signal. And digital to analog system is also works on the same principle. And there are so many types of ADC and DAC, ladder circuit, 2n type of circuit is available. But here only we are seeing the simple block diagram of the analog to digital converter. So block diagram of the analog to digital converter was like this. Now let's see the block diagram of the digital to analog converter. This is digital to analog converter. So digital to analog converter is having this type of block diagram. So first of all, digital input is given to the digitally controlled switches. So here digital input is given to this digitally controlled switch. So MCB and LSB, that means 0, 1, 0, 1, 1, 1, 0, 0. This type of input is given to this digitally controlled switch. Now this digitally controlled switch is controlling the resistive network. And this resistive network is having input voltage from this voltage reference, that is VR. Now at the different time of the digital signals, or you can say that at the different value of the digital input, So at different values of the digital input, this resistive circuit will behave as the optical current. Either it should give the optical current or it is converted into the current to the voltage converter. And finally, if it is converted by this voltage converter, an analog output is taken. So by this block diagram also, you can take the output as in form of the analog signal. So digital input is given to this block. This block is giving signal to this resistive circuit. This resistive circuit will give you the current, and that current is converted into the voltage by means calculating circuit. This is a calculating circuit kind of, and this circuit will give you the output, that is analog voltage. So in this way, this block diagram of the digital to analog converter is used. So in this video, we have seen the different type of the analog to digital converters block diagram and digital to analog converters block diagram. There are so many types of converter is available, but here we are only talking about the block diagram of such system. Thanks for watching this video. Stay tuned.